So the definite integral. The definite integral, and I'm going to write this down again, just so that I can have it in the video, is defined as the integral from a to b of f of x dx equals, sometimes it's written like this. And what this means, what this notation means, is f of b minus f of a. Okay, and this is where f of x, capital F of x, is the antiderivative of f of x. Okay? So for example, you may be asked to evaluate something like this. What is the value of this definite integral? How much area is under this curve of y equals x squared from 0 to 1? That's essentially what this question is asking. Okay? Now, visually, what this looks like is here's 0, here's 1. We're looking at this. Okay, how do we calculate it? Well, we integrate this. Okay, so capital F of x, which is considered the antiderivative of x squared, will be 1 over 3 x cubed plus c. So, f of x, rather, from 0 to 1 is going to be f of 1 minus f of 0. And that is 1 over 3 times 1 cubed plus c minus 1 over 3 times 0 cubed plus c. And actually, I'm going to run out of space down here, so I'm just going to continue this over here. Maybe you guys wrote smaller than I did, though. That works out to be 1/3 plus c, and then this is minus 0 minus c, which is just 1/3. Okay, so the amount of area under the curve from here to here is equal to 1/3. Yeah? We'll talk about that in a sec. Okay? All right. Here we are looking at the definite integral from 3 to 6 of 1 over x dx. So here, again, the graph of 1 over x, we kind of just looked at this, right? Here's 3, here's 6. We're looking at that. Okay? All right, so this is going to, if we have our capital F of x, the antiderivative of 1 over x would be ln x, ln absolute value of x, plus c. So this guy over here is going to be equal to ln absolute value of x from 3 to 6, which is ln 6 minus ln 3. Okay, now this we can use log laws to write as a single logarithm. because they have the same base, right? So we can write this as the ln of 6 over 3, which is ln 2. Actually, you're right. I missed something in here. I missed the c, right? Yes. You're about to ask about the c's. Okay, so let's talk about that. What's going to happen with the c's? Yeah. Yeah. The c will always equal 0, right? Because if we take the difference of the value of this definite integral at 2 points, we're always going to have in there c minus c, right? So as long as we're evaluating a definite integral, we could ignore the c. If it is an indefinite integral, meaning we are not evaluating the integral at any given value of x, we have to have the c there because the indefinite integral represents a family of functions, right? They could be at all different heights along the y-axis. It's that family of functions, okay? But if we are just subtracting, taking the difference, which is essentially what a definite integral, what we're doing, then yes, you're right. We can eliminate the c because at the end of the day, it's not going to factor in. Yeah.
So do we have to write it?
You don't. No. You don't. Oh, I did put the c in there. I didn't forget it down there. Okay. You can make a note of that, right? So I'll put this at the bottom. You don't need to include the constant c for an indefinite, or sorry, not indefinite, definite, that's what I meant to say, integral, because when you subtract, c minus c equals 0. And at the end of the day, all we're really concerned about is what's the value of the definite integral. Okay? All right. Integral from 2 to 4 of x cubed minus 6x squared plus x minus 1. So here our f of x is going to be 1 over 4x to the 4 minus 6x cubed, well, times a third, okay, over 3 plus 1/2 x squared minus x. And this, I suppose, we could turn into a 2 minus 2x cubed. 6 over 3 is 2. So this guy is going to be essentially 1 over 4x to the 4 minus 2x cubed plus 1/2 x squared minus x from what to what? 2 to 4. Okay, so this can kind of be painful sometimes because we expect exact values. Yeah, we expect exact values. Sometimes it's a bit of a pain. So this is going to give us 1 over 4 times 4 to the 4 minus 2 times 4 cubed minus 1/2 times 4 squared minus 4 minus 1 over 4 times 2 to the 4 minus 2 times 2 cubed plus a half times 2 squared minus 2. Just be glad. I can't remember if you guys get a scientific calculator next year. Just be glad you have one now. Okay, so anyway, what is that? A quarter times 4 to the 4 is 4 cubed, so that's what, 64? And then this is 2 times 4 cubed, 64 times 2, 128, minus 128. And then half times 4 squared, 8, thank you, minus 8, plus 8, thank you, minus 4. See, that's the kind of thing that happens. It's a pain. You probably, if I was the person marking like in university or your test coming up soon, I wouldn't take any marks off for that. It's a copy, it's a little copying error. You know what you're doing. Okay, minus. Okay, so a half times 2 to the 4 is 16, so times a quarter is 4. Minus 2 times 2 cubed, that's 2 to the 4, so that's what, 16? Plus a half times 4 is 2, minus 2. So that is, okay, what is that? Negative 64 plus 4, negative 60, minus negative 12. Okay. Oh, this is just getting started. Wait till what we're going to do on the next page. Okay, and that is negative 48. There we go. Okay, now one thing I should mention. I keep talking about area, right? So what was our answer here? Negative. Okay, so here's the deal. Area is a visual representation of multiplication. It's not, that's, to be clear, area is a measure of two-dimensional space. That's what area is. But area is, multiplication can be modeled visually using area, right? So it's not a perfect model because what's probably happening here is that the curve, I don't know exactly what this is going to look like, but some of this is below the x-axis. And so some of those y values are negative. And so although the x values are positive, we're looking from 2 to 4, if you're thinking about multiplying x times y to get area, right? Because the area that we're thinking of here is really it's a representation. We're using area to model multiplication. And so definite integrals represent multiplication of these x values times the y values, not always just area, okay? If you are asked to evaluate a definite integral, those can be negative. If you are asked for the area that is bound by a curve and the x-axis, which we're going to do tomorrow, that always has to be positive. Because area, which is a measure of two-dimensional space, is positive. Okay? So that we'll look at tomorrow. Definite integrals can be negative, but if the question says determine the area bound by this curve in the x-axis from this x value to this x value, that must be positive. And we'll talk about how to deal with that again tomorrow. I know that you guys are all like dying from the suspense, but you'll survive. Okay. So here we have the integral from 1 to 2 of 1 over x minus 2 all squared over x squared dx. Okay. What do you think we have to do here? Yes? Yes, something like that. We're going to have to use a trick, right? Or a tool. We're going to have to undo something, okay? So one thing I'm going to do first is just rewrite this so that everyone can see a little better. And I'm also, while I rewrite it, going to write it this way. Nope, scratch that. I changed my mind. I'm going to write it this way. Okay, so I'm hoping that firstly you can see that a little more clearly, and secondly that perhaps it might give you an idea as to what direction to take. Because we have these two tools, right? We've got substitution rule, which undoes the chain rule, and the product rule, or sorry, the integration by parts, which undoes the product rule. Yep. It's not integration by parts, actually. Okay, so this one is substitution. Now, what you want to look for is this. With substitution, you want to look for, do I see parts anywhere in here where I have part of a function and its derivative? So if you have anything that's either polynomial or anything with a power, with any powers, right? Anything with an exponent, look to see if you have ones where one is one more than the other, because then you are taking the derivative of something, right? When you do the chain rule, you have to take the derivative of like an inside function, right? So here I can say, okay, that's to the -1, that's to the -2. That's one less than that one, okay? Typically, integration by parts, the two parts will be different types of functions. So one might be a polynomial and one might be a trig function, right? Or one might be a trig function and one might be an exponential function or something like that. Okay, so that's something that you can look out for. Because I think what we've done so far is we've looked at each of these types of rules in isolation, right? So I've been like, let's practice substitution. Let's practice integration by parts. But we haven't seen questions where it's like, oh, I don't know what to do here. Okay, so these are some things that you can look out for. Okay, now, when you are choosing for substitution, like what should be u and what should be v, the one that's the derivative is going to be, or sorry, what should be u. When you're using substitution, you define u, and then you find du by dx, right? Pick u to be the one that's not the derivative, right? So this guy, the x to the -2, that's the one that's where the exponent's been decreased by 1. So this needs to be our u. That's not so clear. Let me fix that. X to the -1 minus 2. Okay? Now, if this is our u, our du by dx is going to be the derivative of x to the -1 is, we bring this in front, so -1 times x to the -2. Well, that's nice, because here's our x to the -2. So we want to see that. Okay? And then, of course, the derivative of -2 is just 0, of the -2. Okay? Now, what we actually need to replace when we do our substitution is we need to replace this. So there's a little bit of manipulation that has to go on here, right? First, I'm going to multiply both sides by dx, so I'm going to have du equals -1 times x to the -2 dx. And then I have to divide by -1. So this is going to be negative du equals x to the negative 2 dx. Okay, and now I'm ready to do all of the substitution. So this is going to become the integral. Now, when you're doing these, when you're just sort of trying to integrate, I mean, I don't really know. Let me talk to my peeps and find out about the 1 and the 2, because to be honest, it doesn't really make sense to put the lower limit of 1 and the upper limit of 2 there, because those apply to the variable x. They don't apply to u, right? And if u equals x to the negative 1 minus 2, then if we wanted to put a lower limit here and an upper limit here, we would actually have to figure out what those would be for u if this is what u is equal in terms of x. Okay, so I would leave those off for now, and then once we do our substitution back, then we could put them back in. Okay, so this is going to be, well, this is u, so u squared times, we're subbing that for negative du. Okay, and I can bring the negative out if I want. And so this is going to be negative 1 over 3 u cubed plus c. And of course, now we're going to go back and sub in the expression that we replaced u with, which is x to the negative 1 minus 2. And so now we could put this 1 and 2 in as the lower limit and the upper limit for x. Okay, so this definite integral, I'm running out of space here, I'm going to have to add space at the end, is going to equal negative 1/3, what was it? X to the negative 1 minus 2 plus c from 1 to 2. Yes? Oh, cubed, thank you, thank you, thank you. Yes, of course. It definitely would be cubed. Okay. Now, if the other one was a pain, this one's going to be a really big pain. But that's okay, we'll do it. I think what I'm going to do is, I don't want to have to push everything down, so I'm going to extend, I'm going to add a page. And then I'll just copy this over, because I took up way more room than I intended to. Okay, so that was negative 1/3 times x, hi. Sure, to the negative 1 minus 2 cubed plus c from 1 to 2? Oh no, what am I doing here? 1 to 2, okay. Okay, so this, and again, I'm going to leave out the c's when I do this. This is essentially going to be negative 1 over 3. In fact, I'm just going to put it as this. 2 to the negative 1 minus 2 over 3. Minus cubed, thank you. 1 to the negative 1 minus 2 over 3. There we go. So the negative, sorry, do you want me to, let me just erase this and clean this up a little bit. It got a little messy in there. There we go. That's better. All right, so let's see. This is going to be 2 2 to the negative 1 is 1/2 minus 2. 1/2 minus 2 is what? Negative 3 over 2? Negative 3 over 2. Okay, this is 1 to the negative 1 is 1 minus 2 cubed. 1 minus 2 is negative 1. Okay, whew. That's okay. All right. We're good so far? Yeah. Yep. Yep. Okay, so this is going to be negative. Well, it's going to be negative, negative, right? Well, it's okay. Let's leave the negative in here first. So 3 cubed is 27, 2 cubed is 8, and negative, negative, negative is negative. So this is going to be negative, negative 27 over 8 over 3. Whew. And then, okay, let's see, minus negative 1 times 1 times 1, wait, hold on. There's 4 negative signs here, right? So that's what, positive? Thank you. 1 over 3. We're almost there. Some of you guys are probably done this whole thing and like leaving me in the dust. I'm like the old lady who's, anyway. It's not that bad. All right, so what have we got here? Negative, negative makes positive. Okay, so 27 over 8 divided by 3 over 1. That's going to be, so that's positive. 27 over 8 divided by 3 over 1, multiplied by the reciprocal, times 1/3, minus 1/3. Okay, nice. The 27 and the 3. We've got a 9 there. 27 divided by 3 is 9. So we've got 9 over 8 minus 1/3. That's not too bad. What's the LCD between 8 and 3? 24. Yep, so this is 27 over 24 minus 8 over 24. 19 over 24. There we go. All done. It can get a bit annoying. Just a bit. Just a tiny bit. Yeah.
Could I do it with the product rule or the integration by parts if I really wanted to?
No,
Or would it not work?
it wouldn't work. No, because integration by parts undoes the product rule. And if you were to take the derivative of this function, you wouldn't use the product rule to do that. Does that make sense? Yeah. Okay. Now we're on to this one. I think this one's going to be easier. I think, but I can't remember. Might not. I'm not making any promises. All right, so we've got the integral from 0 to 2 of 2t cubed plus t times e to the t to the 4 plus t squared dt. Okay, how are we going to do this? Yeah. Yeah, substitution again. How did you know? Yeah, so that's a good guess, right? The exponents here are 4 and 2, and here they're 3 and 1. So if you were to take the derivative of something with exponents 4 and 2, you would get a polynomial function with with exponents 3 and 1, right? So that's a good strategy to start with, absolutely, okay? And what would you call u? Absolutely. Okay, and then I think I'm writing backwards today. du by dt equals 4t cubed plus 2t. Okay, now that's not exactly what we want to replace. We want to replace 2t cubed plus t. So how are we going to do that? Factor out of 2. Yeah, exactly. So we're going to get du by dt equals 2 times 2t cubed plus t. There we go. And then we need to multiply by dt, divide by 2, right? So we're going to get du over 2 equals 2t cubed plus t dt. And now we can do all the substituting we need to do. So this will become the integral of e to the u times du over 2. And I will bring out the 2. Yeah, du, there we go. And that, of course, is just equal to e to the u plus c, right? Now, that's kind of nicer to deal with. We can now go ahead and sub our u back in, or t to the 4 plus t squared in for u. So this definite integral will be e to the power t to the 4 plus t squared. And then because it's, oh wait, that's a really big bracket. Because it's definite, we can leave out the c as long as we do this. Right, thank you. It does. Yes. The 1/2 does have to be there. Totally. Okay, and this will be one half times e to the 2 to the 4 plus 2 squared minus 1/2 times e to the 0 to the 4 plus 0 squared. And that's, okay, so 2 to the 4 is 16 plus 4, so that's e to the 20. And then this is e to the 0, which is 1. And they are both times 1/2, so I can make this a denominator of 2. There we go. Okay, last but not least. What strategy are we going to use here? Yeah. There you go, integration by parts, yeah. Okay, and then what should we make u and what should we make v prime? Harry?
X should be u and v prime should be cosine.
Okay, so do you guys, this x should be u, and cos x should be v prime. And how did you make that decision? Yeah, that's right. So it's the L-I-A-T-E, right? Good. Okay, so if x is u, then du is equal to 1. And if v prime is cos x dx, then what would v be? Sine, that's right, because the derivative of sine is cos x. So if we're going the other way, then this has to be sine. Okay, so here, if I'm looking at, I'm going to rewrite this underneath because I just have so little space over here. The integral from 0 to, was it pi over 2, I think, of x cos x dx. Then remember we've got the integral of u v prime equals u times v minus the integral of v u prime. Or you could write it as u prime v. I think that's usually how you get it, right? There you go. U prime v. Okay, so we just basically need to plunk everything in right now, right? This is essentially going to be u times v, so that's x times sine x. Now what we have to do here is we actually have to put in that 0 to, well, actually no, we could save this at the end. Yeah, we could do it here. Those limits in right there, because there's no integral in that piece of it. And then minus the integral of u prime, which is, oh, this should be 1 dx. There we go. Dx times sine x. And these also will have the same values. Okay. So I'm just going to leave this first part for now because we'll do all of the evaluating at the end. Okay, so what's the antiderivative of sine x? Negative cos x, that's right. Because the derivative of cos x is negative sine x. So if we have positive sine x, this would have to be negative cos x. And here we have to put this in as well. Right, and then actually we can just combine the two because they have the same lower and upper limits. So this is basically going to equal pi by 2 times sine pi by 2 plus cos pi by 2 minus 0 times sine of 0 plus cos 0. And this is, let's see, so pi by 2 times sine pi by 2 is 1. And then cos of pi by 2 is 0. That's 0 because it's 0 times, well, sine 0 is also 0. 0 times 0 is 0. And the cos of 0? 1, that's right. Okay, so all together, this is pi by 2 minus 1. All right, Any questions so far? Okay. So I am going to stop there for today.